Oxidation. Oxidation is the loss of electrons or an increase in oxidation state. One way to recognize oxidation is when oxygen is added to a molecule, hydrogen is removed, or when bonds to highly electronegative atoms increase. Common oxidizing agents you should know for the MCAT include oxygen, potassium permanganate, and chromium trioxide. In organic chemistry, oxidation is what allows alcohols to transform. A primary alcohol can be oxidized into an aldehyde and then further into a carboxylic acid, while a secondary alcohol is oxidized into a ketone. Reduction. A reduction is the gain of electrons or a decrease in oxidation state. You can often recognize it when hydrogen atoms are added to a molecule, oxygen atoms are removed, or bonds to electronegative atoms decrease. Common reducing agents include lithium aluminum hydride, LiAlH4, which is very powerful, and sodium borohydride, NaBH4, which is milder and more selective. On the MCAT, you'll frequently see reduction when aldehydes or ketones are converted into alcohols. Oxidation states, also called oxidation numbers, are a way to assign charges to atoms so we can track electron flow in a reaction. There are simple rules to follow. An element in its standard state, like O2 or N2, has an oxidation state of 0. The sum of all oxidation states in a neutral compound must equal 0. Oxygen usually has an oxidation state of -2, and hydrogen usually has +1. But be careful, there are exceptions. For example, in peroxides, oxygen has an oxidation state of -1. These rules are tested heavily on the MCAT, especially when you need to decide whether oxidation or reduction has occurred. Alkenes are especially important in redox reactions. They can be oxidized with reagents such as osmium tetroxide or potassium permanganate to form diols, which are molecules with 2 hydroxyl groups. On the other hand, alkenes can also be reduced. When you treat an alkene with catalytic hydrogenation, hydrogen atoms add across the double bond, and the molecule becomes an alkane. On the MCAT, always look for bond changes. When the molecule gains more carbon-oxygen bonds, it is being oxidized, and when it gains more carbon-hydrogen bonds, it is being reduced. Aromatic compounds. Aromatic compounds, such as benzene rings, are more resistant to direct oxidation or reduction because of their stability. However, the side chains attached to the ring can be oxidized. For example, a methyl group on a benzene ring can be oxidized into a carboxylic acid. The MCAT often tests this concept in metabolism or drug chemistry, where aromatic groups show up frequently. Biological systems. In biological systems, redox reactions are central to life. Every time your cells use oxygen, redox reactions are happening. Molecules like nicotinamide adenine dinucleotide, NAD+, are reduced to nicotinamide adenine dinucleotide plus hydrogen, NADH, and flavin adenine dinucleotide, FAD, is reduced to flavin adenine dinucleotide hydride, FADH2. These reduced electron carriers then donate their electrons to the electron transport chain, which is how your cells produce adenosine triphosphate, ATP. If you see NADH or FADH2 in an MCAT passage, the key question is whether the molecule is being oxidized or reduced. So that's oxidation and reduction reactions, from electron transfers and oxidation states to alcohol conversions, alkenes, and even biological redox carriers like NADH and FADH2. On the MCAT, it's less about memorizing reagents and more about tracking what's being oxidized and what's being reduced in the passage or question. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.